Welcome to lesson 8.7. This is the last lesson in topic 8 and the last lesson of our 6th grade math. Today we're going to learn to summarize data distributions. We're going to pull all this together. For part 1, we're looking at data distributions that are symmetric. Remember, symmetric are kind of like mirror images of each other. More or less. This isn't going to be exactly symmetrical necessarily, but in general it is. So we have a science class that's testing how different types of fertilizer affect the growth of plants. And we have this dot plot to show the height of plants after being grown in the science lab. Okay, so as we look at this, we had one plant that was 14 centimeters tall. We have 2 that are 15, 3 that are 16, 2 that are 17, and then 118 and 119 centimeter tall plant, right? So as I look at this data, I want to first kind of take the big picture look. Do you see any outliers? And I really don't. I don't see any big gaps between a data point and the rest of it. We do have roughly symmetrical data. It's the highest right here. And then it kind of has a symmetrical shape, right, as it goes off. Clusters, well, most of the data seems to be kind of in this 15 to 17 range. So that's kind of a general overview of what we're looking at. With no outliers and pretty much symmetrical data, the mean becomes a really good measure of center, and the mean absolute deviation is a great measure of variability. So we're going to go ahead and calculate those. So here's a list of all my heights. I pulled that right off the dot plot. I'm going to add them up, and I get 163. Now I'm going to calculate the mean, and I get 16 3/10. Now I need to calculate the deviation of all my data points from the mean. How far each of those heights are from the mean of 16 3/10. So if I take 16 3/10 and subtract 14, I get 2 3/10. I can go ahead and do that for all the points here. So there they are. Now I need to find the mean of the deviations, or the mean absolute deviation. So if I add those up, I get 11 6/10. And so for the mean absolute deviation, I get the sum divided by the number of scores, which is 1 1600ths. And so what does that mean? That means the average distance of a data point from the mean is 1 1600ths centimeters. So the data is pretty closely clustered together. So we have a question: does the shape of the distribution, that picture that we looked at with the dot plot, does that match what we found by finding the measures of center and variability? And I would say it does. Coming back to our dot plot, 16.3, the mean is right there. And look where most of the data is. So yes, most data is clustered around the mean. All right, we're on to part 2, and you can see I made a correction here to your packet. That's because of spell check. You gotta love it. Summarize a distribution that is not symmetrical. That's what we're looking for, not systematic. So there we go. A fat content in grams was measured for one slice of pizza. That's 1/8 of a pizza, of 24 different 12-inch pizzas. And we have some data displayed on this dot plot. And we want to know how the data can be used to describe fat content for any slice of pizza. In other words, your typical slice. So I'm looking here, and first off, I notice I don't really see symmetry here. I see a bunch of stuff over here is clustered together. I see a little bit over here, and then some tailing off here, and 1 point over here. Not really symmetrical in the same sense that our last example was. I also do see kind of a cluster here and a gap here, and I have these 2 outliers, I would say. We also might call this an outlier. That's kind of borderline whether you'd call it an outlier or not. It's kind of close to the main body of the data, but there is a gap between. So anyway, looking here, we have outliers. So outliers, as you recall, throw off the mean. So we're going to look to use the median here. The median is a better measure of center. So why is median the better measure of center? Well, because we have the outliers and because we have non-symmetrical data. Symmetrical data really is something that would point you towards the mean, and this is not. Now, because we're using median, we're going to go with the IQR, or the interquartile range. The interquartile range, as you might remember, goes with median because outliers don't really affect the interquartile range either. All right, now we're going to try to summarize distribution from a box plot. So we have this box plot for the number of days the temperature was above 80 in July. It does do things for us. It breaks our data up into quartiles. There's 25%, that little piece right there. Here's 25%, here's 25%, and here's 25%. So a lot of data is clustered down at this lower end of number of days. 1/4 of the points only had 2 or 3 days of above 80, and we had another 25% that was spread out in this big range. So we kind of see this data is not really symmetrical. It's kind of pushed to one side. The median score is not in the middle. Go ahead and read each of these questions and see if you can give them a true or a false by looking at that box plot. And your very last straight up practice, we have 5 different students who measured the length of a shadow in inches. One got 38, one got 38.5, 37 3/4, another 38, and a 38 1/4. And we want to make some generalizations about the data distribution of these measurements. So we're going to find the mean, median, and interquartile range of this data set. Just look at this, put this on a dot plot, right? Put it on a dot plot and look for outliers, look for clusters, look for symmetrical data. I'll get you started with a setup on this. Looks like there's nothing smaller than 37, nothing bigger than 39. Right in the middle is 38. And I have some quarters, so I'll just break these into quarters, just like so. And then you should be able to plot your data pretty easily. All right, give it a shot. See you next time, which would be the practice test. Wow.